Sounds good.
All right, so welcome everyone to the August 15th Resource Management Working Group meeting. We have one item on the agenda today. Ed, the floor is yours.
Cool. Let me go ahead and share a screen and kick off some slides. So essentially, I'm here today to talk to you guys about network service mesh. And effectively, network service mesh you can think of this way. You know, we're all familiar with Istio and the stuff that it does for normal sort of application networking at layer 4 through layer 7, you know, TCP connections, HTTP connections, all of that stuff. And that's awesome. And we've got a whole set of use cases that people have around NFV, you know, multi-network, physical NICs, SRIOV, a whole laundry list of things where it turns out that you can apply the same smart things that are being done in service mesh. You can apply analogs to them to your L2 and L3 networking traffic. And so we call that concept network service mesh. And one of the things that it does that's really nice is it allows you to use the existing device plugin API with no alterations in order to achieve your ends. So we don't need to do all kinds of weird things to change the device plugin API in order to properly support hardware NICs, SRIOV, all of that stuff. It actually flows very smoothly from that model. And so it seemed to me in talking with Vish that this would be something you guys would be interested in, because I know that these are use cases that are being brought to you, and you've been very good about recognizing the importance of these use cases, but there have been a whole variety of fairly major changes being proposed to try and address them. And so a big part of what I'll show you here today is, at least if you take the network service mesh route for solving these use cases, we don't have to go do massive changes to device plugin or Kubernetes. Sound about good as a starting point?
Yeah, I think it's probably a good starting point. I'm sure there'll be questions as you go through your presentation.
And so what I'm going to do in this presentation, I'm not going to do the whole deep dive into network service mesh because most of it is not necessarily directly relevant to the resource management working group, although I'd be happy to do that if you guys would like. What I'm going to do is start with a very simple narrative story that talks about how we would handle physical NICs with wiring physical NICs into pods, using the existing device plugin API without having to make changes to it. So it's been my experience that people do much better with stories. And so this is sort of a narrative introduction to this particular use case. Can everyone see my screen?
Yeah, looks good. I see Hannah and the hardware NICs.
Excellent. So we have several stories like this. So this is a chapter in our overall narrative deck. So meet Hannah. Hannah is writing a Kubernetes app to be deployed on her on-prem Kubernetes cluster. And one of the pods in her app needs to use some hardware NIC. Now, some of the nodes in Hannah's Kubernetes cluster have special hardware NICs. Some don't. So this intrinsically becomes a resource and scheduling problem. But it's not as simple as I want a hardware NIC, because not all the special hardware NICs are the same. Not all of them are connected to the same network, right? Some of them are connected to various different networks. And even when you talk about NICs connecting to the same network, some of them will have different speeds, so 10 gig versus 100 gig. And so those aren't really giving her the same resource in this situation. And not all of those NICs are being treated the same by the network they connect to. Right, so on node 6, that hardware NIC may have a bunch of ACLs being applied when it talks to the network. On node 8, there may be a bunch of quality of service marking that's going on when that NIC connects to the network. And so you can't actually think about this from a resource point of view in terms of the generic, I want a hardware NIC, because that's insane, right? A hardware NIC is useless to you without some knowledge of what's being provided on it. You can't think about it in terms of the network the NIC connects to, because that doesn't actually describe the network service that's being provided either. Nor can you think of it solely in terms of the network plus the speed of the NIC. It turns out that actually what you're really getting when you're looking for this physical hardware resource is a particular kind of network service that could encompass all kinds of properties. So, but this complication is not actually how Hannah sees her world, right? From her point of view, the problem looks like this. She has a pod that has to be scheduled so that it can connect to somewhere where there's the hardware NIC that she needs, and that NIC has to be injected into her pod. So This is a very simple thing from Hannah's point of view. But this is a problem because you've got all these hardware NICs, and so she has to figure out how she is going to get scheduled to them, right? So if you were to put her in a situation where she had to pick a particular named device, she would have to know about the NICs in the cluster, what services are provided to the various hardware NICs, how to pick the node and hardware, which is something you really want a scheduler to do, avoiding conflict with people who are already using that node and hardware NIC. And so this is where we sort of enter in with our little cartoon character from Network Service Mesh. This is Ariadne, the NSM, the Network Service Mesh spider. So she's sort of our mascot. So really quickly, just another brief introduction here. So what is Network Service Mesh? It's sort of like Istio, but for L2 and L3 protocols, right? So when you're dealing with Istio, your payloads are HTTP messages or TCP streams. Here, the payloads really are IP and Ethernet and other things like that. So if we go back to look at Hannah's problem, right? She just wants to be able to deploy a pod and get one of the hardware interfaces that she needs injected into it. She doesn't want to have to think about which hardware interface NIC to pick a particular one in the cluster. She doesn't want to have to think about what node it's on. She doesn't want to have to think about, wind up with some hardware NIC that doesn't do the thing that she needs. And of course, she also still wants to get her normal Kubernetes networking through the normal Kubernetes interface that gets injected into her pod, right? So from her point of view, this is very simple, but it's not something that's straightforward in terms of how it's going to happen. So obviously, because we're talking about physical resources, the first thing that comes to mind is to look at the device plugin API, because it does a really good job of handling physical resources generally. Unfortunately, it doesn't quite get us there. And the reason it doesn't quite get us there is basically fundamentally because at the point the device plugin is being asked to handle the allocation of devices, we don't actually have the information we need to handle the networkingness of NICs. And at the point we get to something like CNI, we're not getting the information to handle the hardwareness in order to configure the networkingness of NICs. So there's a disconnect there. There have been a lot of proposals about smashing these two together in order to solve this disconnect, but I think that just massively complicates a beautifully elegant and simple device plugin mechanism unnecessarily. The other thing to note is that the networkingness that Hannah is seeking is not actually Kubernetes networkingness that she gets from CNI, right? She's literally looking for a hardware NIC. That hardware NIC is going to provide a radically different network service than what you're getting from Kubernetes intrinsically. That's part of why you're asking for a hardware NIC. And it can't just, again, be a generic hardware NIC. You can't say, I've got 20 hardware NICs in my cluster, give me a hardware NIC. Because what that NIC is plugged into and the characteristics of the service being provided for it by being plugged into something is very realistically different. So you can't just say something like, well, give me a hardware NIC or give me an SRIOV NIC and expect to get any meaningfully useful response. And of course, this results in sad panda. Any questions so far?
No, this makes sense.
Okay, good. Always happy to know that it makes sense. So this is where we sort of get to how network service mesh could start helping, right? So network service mesh thinks about things in terms of three basic concepts. The first is a network service. It's the abstract thing that you wish would happen when you shove packets or frames on that particular interface. It could include things about QoS, ACLs, connectivity to special networks, a whole variety of things, security, firewall, IDS, I don't care, right? From network service mesh's point of view, it is a thing that you want in the abstract, right? So this, for Hannah's problem, this is the stuff that's provided by the hardware NICs in her cluster that do the thing that she needs, right? So if there are 20 hardware NICs, maybe 4 of them actually can provide the network service she's looking for. And then the second concept is a network service endpoint. It's a concrete thing that provides an instance of that network service, right? So if you've got 20 NICs in the cluster, 4 of them can do the thing that Hannah needs. That means that you have 4 network service endpoints for that network service available in the cluster. So, and again, it's the top of rack switch port that is basically being plugged into by that hardware NIC is really the thing is the network service endpoint there. The NIC itself is just a conduit to that network service endpoint. It doesn't provide it itself. In some sense, this is basically making the point that what matters is not so much the end of the NIC in the server. What matters is the end of the NIC in the top of rack switch. Right, and then the third concept we have is L2 and L3 connections between your pod and the network service endpoint. Right, so Hannah's pod gets something that looks like a kernel interface that she can shove packets in Ethernet frames into and get connected to something providing the network service that she wants. So, Hannah's fairly bright, so she immediately gets this concept, and physically it looks sort of like this. You've got the port in the top of rack switch that's the network service endpoint. You've got the hardware NIC that is essentially giving her the L2, L3 connection to that she's looking for. Everything still making good sense to folks?
I think it's worth continuing to go through the story. I mean, I think some of us will have to go back and re-review aspects of the story.
Okay, cool. We can definitely do that when we sort of shunted through this a little bit. So how do you use this is sort of the central question. We got these three abstract concepts, right? So in network service mesh, we have a CRD that we call a network service. You give it a name, and it exposes channels. You can think of this as being an analog to services in Kubernetes, and think of channels as being an analog to ports. The big difference here is that we focus on the payload rather than necessarily on the transport. Please note, network service does a lot more than handling hardware NICs, so there are a few more handles here than you would do if you were doing a completely bespoke solution for hardware NICs. And of course, what this network service is really doing as an abstract is representing that class of hardware NICs that do the thing that Hannah needs. So, and then the pod spec, you just treat it like any other resource, right? So you have network service mesh.io/enhanced corporate connectivity, if enhanced corporate connectivity is the name of your network service. And this is right and appropriate because you really are asking for a physical resource. You're asking for some hardware NIC that is able to provide you this network service in the cluster. And then that particular resource gets advertised as a device plugin in the normal sort of way. So all the normal scheduling that works well for device plugin API, all of that works. But there's still this problem of the networkiness of this NIC, right? It's all well and good to say we're allocating it, but particularly for hardware NICs that are not SRIOV, we're not just talking about shoving a device back at the pod. We're talking about an interface, and that has networkiness to it. So in Network Service Mesh, there's something called the Network Service Manager, or NSM. It runs as a daemon set. So you have one of them on each node, and it handles the networkiness for a bunch of Network Service Mesh stuff, including but not limited to the hardware NIC case. So when Hannah runs her pod, it gets scheduled in the normal way by the device plugin API and the normal scheduler in Kubernetes. And she would need to run it with a network service mesh init container and a config map that basically says, look, this is the kind of network service that I want.
So just a question there. Is this basically the equivalent of like a sidecar container in Istio? And then
it's really conceptually close. So if for the time being you shorthand it that way in your head, you are not too far off.
Which container is actually making the request for the counted resource associated with the device plugin? Is it that init container?
No. So the resource request gets to the device plugin is still handled by kubelet in the normal way.
No, but which container is making that request? Is it this init container?
No. So my understanding, and correct me if I'm wrong, but my understanding is that normally kubelet has a device manager of scheduling. So the plugin gets scheduled out to a particular kubelet on a particular node.
No, let me crisp up my question. Pods don't make resource requests.
And this one does not make a resource request either.
No, but containers do. So in your previous slide, you showed a counted resource for your device plugin associated.
Yep.
And no, I'm asking if that snippet is the init container you're discussing, or is that the Hannah's normal container?
That's the normal container. This is not the init container I'm discussing here.
Okay.
And then there is a little bit of funkiness there because when you're talking about networkiness, typically we scope the networkiness to pods and not to containers. So there's a little bit of fuzziness there. I absolutely agree. So effectively here, when you run your pod, you run it with an init container and a config map. And in networks, the init container is not rocket science. There's no reason to write more than one of them. So network service mesh is literally writing one, and it just takes a config map. So you can basically say, hey, I want this network service, and by the way, I'd like it as a hardware NIC. And since you've already been scheduled and allocated the hardware NIC, it's a perfectly valid thing for you to be able to add to the request connection that you send to the network service manager. Now, the network service manager is basically handling the networkiness of this stuff. And so it gets the request for the hardware NIC with some kind of token indicating that you have in fact been, that would be set by an environment variable indicating that you have in fact been allocated this hardware NIC. And then based upon that, it will inject that hardware NIC, let the init container know that this work has been done, and will basically finish, the init container exits and the pod proceeds normally. So fairly straightforward and simple, and no actual changes to the device plugin API. It in the scheduling works exactly the way it always has. This is just dealing with the networkiness part of the problem.
Which mechanism it uses to inject the NIC into the pod? Is it
Sorry,
CLI? Which interface it uses to inject the pod? Is it directly talking to kernel, or is it CLI interface?
So the network service manager is handling that directly. We do not use CNI in this because this is actually not a problem that CNI is terribly well scoped for. CNI works really, really well for handling the Kubernetes networking stuff. But here we're literally just talking about injecting a hardware NIC into the system. And we do this for a lot of other things as well, where you explicitly aren't looking for Kubernetes network services when you're trying to wire up network service meshes. So yeah, this is not going through CNI at all. This is not part of the CNI lifecycle. And this is part of how we escape the trap that you have that I pointed out earlier, where the device plugin doesn't know enough to be helpful with networkiness because that's not knowable at that point. And the CNI doesn't get the necessary information to be able to do anything. So we literally don't have that problem because we don't actually fall into that trap.
How do you get the right name of a network namespace where you need to inject?
Turns out you can pull the inode for the network namespace straight out of proc. And so that's actually not that hard a problem. You pass it along with the request connection.
So it's init container which just gets the namespace of a pod and then requested to your daemon.
Yep.
Okay.
Yep. It took a couple of hours to figure out how to get the namespace out of the pod, but it turns out to be fundamentally simple once you know the trick. Cool.
I have a question, if you don't mind. It's a pretty basic question.
Sure.
This approach is very network-centric. The real problem we were trying to solve originally was you wanted a device with some specific properties, right? So in Kubernetes terms, if you had a resource name, and if you could annotate that with some specific properties in some form, your user could have simply asked for a device with those properties in standard Kubernetes terms. It would not be network-centric at all, right?
Right. So one thing to keep in mind here is effectively what we've done here is, so there are two ways you can look at this problem. In a lot of the situations I've seen, the original ways that the name of a resource was being used was as defining a class of hardware, right? And so you see things like the SRIOV device plugin. Now, an SRIOV in isolation is not all that interesting. Now, there are all kinds of interesting discussions you can make about adding various properties to devices, and some of those may prove to be entirely fruitful. But the thing that we've realized here is, at least when you talk about networks and network services, because we're dealing with network services in the generic, and they're simply named things, that you don't have to burden the user with figuring out a broad collection of properties. Just like if you're a user who's consuming a service, you don't want to have to understand broad collections of properties about the container running that service. You want that to be summarized in a service name that you're asking for. What we do here, which is very, very useful for this use case and may prove fruitful for others, is we're simply saying, look, you're asking for a piece of hardware that can do a particular kind of function. And rather than making the developer have to deal with a laundry list of complicated properties that may shift and flow, simply summarize that in the I want an X problem. And this is very keeping in my mind in the spirit of the way the device plugin works today, where you simply say, I have a string that represents a resource that I want. It's a finite physical resource somewhere. And then I can schedule based on that string and the count of things that I need and the count of things that are supposedly available for allocation. Make sense?
Okay. Sure.
Yeah, I do not deny that there may be cases where a complicated enumeration of properties may prove to be fruitful. It just seems like overkill in many, many cases, including this one.
Okay.
Cool.
Thank you. Sure.
Yep. But no, excellent question though. Cool. So then, of course, you just use the device plugin mechanisms in the normal way to schedule the resource for the hardware NIC. So nothing has to change here about the device plugin API.
So this is the part I'm confused on though, because I thought, in theory, there are things you might want to change, right? Because you might want to share that NIC across multiple containers in the pod, right?
Well, so one of the things that I'm presuming here is that a pod has a single network namespace. And so if I'm talking about injecting a NIC into a pod, I am talking intrinsically about injecting that hardware NIC into a network namespace, which means that it is intrinsically shared across the entire pod. That's just the nature of the way pods and network namespaces work in Kubernetes today.
But it's not the nature of resource requests or requirements work in Kubernetes today.
This is true. So there is a fuzzy side effect here, which is that if a container makes a request for a hardware NIC for that container in that pod, that NIC, by virtue of the way that networking is fundamentally handled in Kubernetes, that NIC will be available to every container in that pod. But
if I make a request for 2 NICs,
you'll get 2 NICs in that pod.
right?
You can request any NICs you want, as long as the resources are available to be scheduled.
I guess what I'm wondering is, this seems like a user story that calls out a nice need for pod level resource requirements.
That's possible.
Because that's basically what you've done here. You've made something pod level that...
I've not intrinsically made it pod level in the sense that that was a choice. It's just that not making it pod level requires what appears to be a major re-architecture of Kubernetes.
There's been other use cases that have come up where having pod level resource requirements would be useful, particularly around like the overhead for certain container runtimes. So
I would find them highly useful. Absolutely. Right. So there is a big gap between I need something to be able to function and God, that would be nice. And pod level resources would definitely be nice.
Yeah. So I guess for me, if you add an asterisk to the story of what would make it better, I would add that asterisk.
So my colleague Sergey is here to talk about some of the other things because he's done some of the work on this in code, and he has a laundry list of this would make life better. But there, like I said, there is a big difference between we have to do a major re-architect in order to make shit work. And
how do you monitor the health of these NICs?
The health of the NICs? We have not yet got to the monitoring of the health of the NICs at this stage. It's important to understand that network service mesh is still under development, right? So we literally have been moving this concept forward for the last 4 months, and that it does quite a lot more than just managing hardware NICs. We also deal with the problem of problems associated with multi-network, NFV, a whole laundry list of things that turn out to map. It turns out a very, very large and complex set of use cases map to a relatively simple set of constructs, which is always a good sign.
Okay, I'm just thinking for the audience of folks on this chat right now, for the areas that have been under discussion for the device plugin API that we feel like would need to change, it was around monitoring and potentially health. So I was just curious if you had any insight on what you would like as a user.
Could you say some of the things they were looking, the problems they were perceiving there?
I mean, Jan's also on the call. I think she could also give her perspective. But I mean, the classic example right now is there was an inability to associate a device to a particular container, which made third parties outside of the GPU use case unable to collect usage data about a particular device to a container for a monitoring standpoint.
Ah, okay, okay. So, from a monitoring standpoint, it depends really on what you want to do in terms of health of a NIC. In networking, you can treat the health of a NIC from something extremely simple like, does the NIC report as being up? All the way to...
Yeah, but also, I just think of the GPU case where there's many other metrics that are tracked associated with the GPU. I don't know the whole host of metrics that might be tracked with a hardware NIC.
Yeah. I mean, part of it, what we're going to have to work out, quite frankly, with a hardware NIC is what are the interesting set of metrics to track to determine health. And right now, there's a huge space of options, so I don't have a concrete opinion about what the right ones are yet. So.
Yes, and also I don't know whether you have followed David Ashpo's device assignment proposal, and I think one of the goal of his work is trying to provide some API for third-party plugins to discover the device assignment information, so that they can associate allocated device with the pod and containers that get assigned.
Yeah, but you're one step ahead of me, Jen. So I guess that was what I was curious if you had a chance to review David's proposal or not.
Which proposal again? I didn't quite make out which proposal.
There's a device assignment proposal cap. We have discussed in the sig-node meeting. I can add the link in the meeting agenda.
That would be brilliant. Thank you, please.
Mm-hmm.
I will go take a look at that.
Yeah, I think you mentioned some of the wish list for the device plugin, and I think some of them may be addressed with the David's proposal.
Cool. I will have a look. Thank you.
I actually have some question about this model. So, so how do you decide the resource name you like ISM want to advertise? Is it based on like some properties you want to enable on the particular hardware?
So when you say, are you asking basically how does one decide on the resource name here?
Yes.
So effectively, it's a fairly simple heuristic. There we go. It's a fairly simple heuristic. Network service mesh IO / the name of the service is effectively what we're looking at, or something, some rough variation of that. Sorry, the name of the network service. Effectively, the name of the network service represents a class of things that are considered to be equivalently good for this purpose. So in this case, I just gave it a very generic name like enhanced connectivity. And that would then match up to the name of the network service in the CRD that the user is asking for.
And then just make sure I understand, that CRD is a cluster scoped resource?
Yes.
Do you have scenarios when one physical NIC can implement multiple services?
Yeah, so that's an interesting problem. There's a whole interesting problem here of trying to sort out and decide how you're going to name the services being provided by a physical NIC. And effectively, I think the situation here we determine is, let's say, for example, I have 3 NICs, and 2 of them can provide service B, and 2 of them can provide service A, but only one of them can provide service A or service B. Is that more or less the thing you're getting at? So there's this overlap between them?
Yeah, for example. Or let's say all 3 of them can implement both A and B at the same time.
Yep. So I mean, in this one, effectively what we're doing as a simplification is you simply map right now a NIC to a network service that NIC provides. And this actually turns out to be relatively about right, because if you go look, for example, at a particular NIC, it has a set of networks that it connects to, a set of services provided to it by those networks, a set of speed characteristics, a set of things that you care about, right? And the set of things that you care about, and some of the things you care about are maybe as simple as this NIC is actually going to something that's running you on the shortest possible fiber between Chicago and New York, right? I mean, there are lots of things that it could be. but effectively, the developer only really cares about one set of characteristics, and that is, does it do this thing that I need to do? And so, yes, we do basically have to peg a nick to a particular choice of name for that class of things. So a nick belongs to exactly one resource name, but many nicks can provide the same resource name.
Yeah, and the SROV case Ed mentioned, I mean, actually illustrates that when a specific, let's say, access to the VLAN 10 can be backed up by a multiple VF instances. And basically, user doesn't really care which specific VF it would use as long as it provides access to the VLAN 10.
Did that answer your question?
Well, not entirely. You had in one of your first pictures, you had like network 1, which had 10 gig connection and 100 gig connection. So from user perspective, I would say I want network 1, and I don't really care what is the speed. However, it might be a second class of users which says I want network 1 and I want 100 gig.
Mm-hmm. Yeah,
so in theory, like this 100 gig NIC is able to provide both, like network 1 and network 1 and 100 gig.
Yep. No. So I mean, what you end up with is do you want to go through and enumerate and have the developer deploying their app have to enumerate the complete set of these specs, and then how do you do the fuzzy matching around them, which can be very semantic and context sensitive. You know, and that's one way of approaching the problem, and I'm sure there are use cases for which it's a valuable way to approach the problem. The approach that we've taken is if you actually care about the difference between the 10 gig NIC and the 100 gig NIC connected to network 1, then you're talking about two different network services that you're dealing with. You know, if you care about that difference. What it really comes down to is users care about a wide variety of things that you have to sort of figure out, but what they typically don't. But if you try and enumerate all of those things and the semantics around them, because those semantics can be complicated, you can wind up with a very, very complicated solution and a very complicated to use solution in many cases. So in some cases, it'll be worth it. In some cases, it won't. So we give you the sort of easy to use version of this problem.
Will you export the 10 gig hardware NIC and 100 gig hardware NIC as separate resources with separate resource names, or they will all use the same resource name?
So if you wish to distinguish those as two separate network services, you could give them two separate resource names. If you wish to treat them as identical network services, you can give them a single network service name across them. It really depends on how you want to define the network services that are being provided. And the main point I make with this is that the things that go into that are enormously more complex than just NIC speed or network you're attached to or any of the rest of it. And so that's going to be a decision on the part of the person deploying the cluster.
Okay, so suppose if I want to differentiate these two types of hardware NICs, so I guess I will need to define two separate network service, CRD, and will they be managed by separate daemon sets?
No, so you need one network service manager per node that can handle all the network services all the network service stuff going on that node. So you only wind up with the one daemon set. So you end up with one network service manager per node. So you can have as many network services as you would like, including as many network service resources here. You would just have the network service manager acting as multiple device plugin APIs for that case, device plugins for that case, because obviously it's going to advertise multiple resources, but you don't have to run entirely separate daemon sets for each one.
Then how does the network manager daemon set pod nodes, which network service CRD it's managed the hardware maps to?
So we're currently, in the POC work we've done around SROV with that, which my colleague Sergey has done, we're doing that with a config map. So you basically push a config map, you bring up the network service mesh daemon set, and it can use that config map to go and map the hardware NICs in that particular node to the network services.
Okay, so the config map, how does it look like? Does it specify some properties the hardware need to match in order to be exported as a certain resource name, or it goes directly mapped to the individual hardware ID?
It's a pure enumeration this time. So it's literally mapping the hardware NICs on that node to the network services as an enumeration. So think of it as a map that has basically think of it as a map structure where the key is the particular hardware NIC and the value is the network service that it is being mapped to.
Okay, so the model basically assumes the nodes in the cluster are kind of static. And if you want to add a new hardware NIC, you want to modify this config map manually to assign it with the proper resource name, I guess.
There are some tricky corners there around dynamically changing that config map that we're still trying to work through. So I'll give you like one classic example. Say you want to change dynamically the config map for a service, but you want to change it to take a NIC that is assigned to service A, and you want to assign that NIC to service B, network service B. But somebody is already using that NIC for network service A. How do you actually handle that problem? How do you handle life cycling of it? There are some interesting things around that. So for right now, we're starting with the sort of static mapping of hardware NICs to network services. And then, as we figure out a little bit more what would be involved in being able to dynamically change that config map as you go, we'll have a better picture.
Yes, it's actually also something we have discussed where we are discussing the new resource API, like as you mentioned, the lifecycle management, whether changing the mapping would affect pods already running or not. I think we actually have some very similar discussions. And I guess the question is whether the logic should be handled by individual like resource management daemon sets, or like we want some generic way to handle that. So I will also add the link of the some later discussions, and maybe we can take a look.
That would be massively, massively helpful. Thank you.
Mm-hmm.
Cool. So let me get back to where we were in the deck. We got quite a bit back there. And then also noting here that you essentially get connected to the right hardware NIC because you're asking not for a particular device ID, you're asking for the network service that is provided. And then, the network service mesh mechanism is handling all the networkiness there for you. So this approach has a few nice things in terms of deployability. So we don't need any changes for this approach to the device plugin API. There are things that would certainly be nice and helpful, but it works out of the box. We also don't need any special CNI plugins because we're basically completely orthogonal to CNI here, because you're not actually asking for Kubernetes network services if you're asking for a hardware NIC. You're asking for a more general network service. Cool. I think that's the end of the deck at this point. So that's...
So I guess, where can one follow this project?
Let me go ahead and grab that link for you really quickly, and I will stick it into, actually, I think I did stick it into the, no, I'm a complete moron. So let me stick that into the meeting minutes. So we have a connection to all of our, in our readme.md at our repo, which is now linked in the meeting minutes. We have the connection to all the resources that we have, including we have weekly meetings at 8 a.m. Friday morning on Zoom. We've got a mailing list, IRC channels, all the rest of that as well. And as I said, we do quite a bit more than just handle hardware NICs. If you guys are interested in any of that, you will find that deck, if you go a little bit further, has a nice narrative introduction to another use case around VPN gateways that doesn't involve hardware NICs at all. So there's a lot of interesting stuff going on there.
Well, I don't know if there are any other following questions, but I guess, Ed, a big thank you for talking about the exciting things you guys are doing with device plugins. It's always good to see the work that we as a community have done get used and validated. So big thank you. And if there are concrete changes that you'd like to see, I know you alluded to the list of things that you'd love to have. I think we'd all love to see those as well, so we can make the experience less fuzzy and clarify things where they could be clarified. So thank you. Are there other topics that we wanted to raise for today? Otherwise, we could adjourn the meeting, and I think this one will be especially useful, so I'll try to make sure to get it uploaded for those who weren't available to review.
Is someone sorry? Is someone going to talk about the wish list listed?
Oh, so Sergey, do you want to talk a little bit about that? So my colleague Sergey actually has done some early implementation for this stuff around SRIOV, and he put together somewhat of a wish list of some of the things that he encountered that might be potentially nice to have. And it might be very productive to talk through that, particularly since I know part of my past experience dealing with you guys is half the time when I've come in and said things like, I think I need deallocate. What I discover is, no, I don't need deallocate. You've already thought that through in a much simpler way. So do you want to take the floor, Sergey?
Yeah, definitely. Let me share. Let me share the page with the list. Just a second. Share. Sure. You know, being a Cisco employee, I don't use Zoom very often, so bear with me while I'm finding the way to share my browser. Just give me a second. What the hell is that? We use mostly a WebEx. Ed, I don't see it in the list of the application. So, oh, yeah, here. So my bad. Okay, so here's your agenda, and basically I put several bullet points, and it's all purely based on the experience I get while developing the SRIV controller for NSM. So one of the interesting discoveries for myself was that the life cycle, I mean, when I started looking at it, it seemed, even though it's working, as Ed mentioned, perfectly now, it could be, I think it could be optimized a little bit, especially since in the networking world, the resources or the network services are a bit more dynamic than the GPU. Example, you install GPU in the server. In most of the cases, basically, you need to power off the server to switch the GPU, to replace it, to add something. In the networking world, the services could be deprovisioned, reprovisioned, changed, modified in certain ways. So, and if we had a little bit better the life cycle management, it would help us a lot. Example, I have a network service for VLAN 10. I like VLAN 10. And currently it has 10 interfaces, which are VFs, and each backed up by 10 gigabit interface. So we upgraded we could add or move, could change the service for VFs provided by another node, which has a 40 gig network card or 100 gig. So basically changing that network service and replacing this VFs by a different VFs, it's very possible, and I don't need to basically I don't need to restart, reload the server. It can be done pretty much on fly. How would I inform the kubelet that these instances are gone or being replaced? Currently, what I do based on the recommendation from Renault was just to mark those VFs as unhealthy and then advertise the new devices. It's working, but and maybe there is a way to make it a little bit more natural, I would say.
I'm curious, have you tried to just like send a new list of devices to Kubernetes without listing the device ID for the old one?
Okay, so I wasn't that part I wasn't aware. I thought that they're kind of a cumulative. No, so basically, the new advertised list would not replace everything there.
It should.
It should. Okay.
Yeah. Could you try it? And if you see any problem, let us know. So we do have some improvements we need to do for the resource lifecycle management. I can send you the document I shared recently listing the why it's in the current status. But basically, if some resource is no longer advertised, we set its capacity to 0 instead of totally removing it. But I actually curious to know like how it affects your use case, like what difference it makes.
I'm also curious, in a similar vein, like what happens with things like if you had a cluster autoscaler. It seems like a lot of the discussion thus far was around like an on-prem use case, but I'm curious how this works with things like autoscaling, where you might have like a homogeneous set of node pools.
Oh yeah, you're right. Currently, I mean, the test I've done was also, mostly done on the bare metal cluster, so we haven't. I haven't tried in the cloud, and you know, getting SRIV in the cloud, I think it's a little bit challenging, but definitely that would be one of the point we will double check.
Yeah, the reason I bring that up is there's another project in the Kubernetes ecosystem called the Cluster API, which has an API called the machine set or a machine deployment, and it basically is providing an abstraction of what you could think of as like an Amazon ISG or an Azure resource template or something, where you can address a set of machines homogenously. And one of their use cases would be to have a bare metal actuator or a deactuator, so you can treat bare metal machines. They can come and go and scale dynamically. And so if you were targeting a bare metal use case, I would be curious, like if I was to pair your work here with that other project, what would be the outcome? And like the assumption typically is that all machines kind of advertise like a homogeneous set of the similar counted resource.
So could you stick a link to the pointer to that in the meeting minutes so we can traverse it? Because that does sound interesting.
Yes.
Yeah, I've been keeping an eye on that project because the multi-cluster is basically one of the interesting new directions in its future. So, but I was mostly working on this one. And if anything, I think I can dig up the link too. So, yeah.
I added it to the bottom of your wish list, just as a pointer.
All right, thanks. All right, so that's the first one. The second one, well, and it's been talked a lot on the Slack channel, it's the allocate and providing a bit more information in the allocate request. And for our case, why it would be useful. It's mostly for the re-provisioning. Let's say we have a pod which is with a bunch of SRIV devices attached to it. What happened if there is a network change? So the network operator, they changed the trunk or they changed the interface which was mapping these VF instances. We need a way to inform the pod, hey, your VF is gone, die or do something about it. Currently, we don't have any feedback which pod uses this specific VF, since there is no pod ID namespace or the namespace name or the pod name in the allocate request. If we had that, then we could think about some logic to informing pod, your VF is no longer available, I mean, just exit. Or some sort of reaction, or even just pushing some log or event, something like that could be extremely useful to the end user.
So I guess this is kind of like you want how to exit gracefully instead of like because normally I expect the container also would die, would fail if the underlying resource just disappears.
Yeah, exactly. You know, one point when the pod is crashing because of something happened with the network interface. Second thing is the crash loop with the message saying your network service is no longer available. So it gives an idea to the operator to react on it. I mean, they might put some hooks on this event or something to gracefully or to do something anyway.
Let me actually ask a question because this may get to the heart of it. If I mark a resource as unhealthy from the device plugin up the device plugin the device manager in Kubelet, and that device is currently in use by a pod, what if any action is taken by Kubelet in that situation?
We currently don't do anything for pods and containers that are already running. We simply deduct the that device count from the allocatable, and its count is still reflected in capacity. So the idea is it's a bit hard to differentiate like a simple device failure versus a device plugin failure, and we don't want to cause dramatic failures if it's a device plugin failure, which can happen frequently during a device plugin upgrade.
That's roughly what I expected the answer to be, because it strikes me as a very hard problem to decide what is the right thing to do in that situation. And probably the least harmful answer to that question is nothing until someone has a really good idea about what we should do that's reliable. And I'm not smart enough to have that idea.
Mm-hmm. Yeah, I think, generally we expect failure handling is handled outside the kubelet. But we can think about whether we need some generic approach. But I don't know whether, I think there are some existing hooks that can check for some health needs of certain things, and I don't know whether you can use them for this use case.
Okay.
All right. Well, and the last two are probably two most requested from you guys. Well, to deal with the container ulimits, because one of the applications we used to test the SRIV was requesting more than default locked memory amount, and it was crashing. So we had to use some workaround with some to be able to extend that locked memory size, so the application would be running successfully. And the second, since SRIV in most of the cases are used in the NFVI scenario with the high performance data plane, things like the CPU pinning and the NUMA allocation or being NUMA aware is very important for a good performance. So that's pretty much what I have.
I think for topology, I think people have discussed that a lot, but it requires a lot of work. And so if you are interested, I think some folks in this group may have better knowledge. For the ulimit, that seems a general sig-node feature. So
Yeah, this has come up in the past, and if I'm not mistaken, not all the limits that people look to set are actually namespaces. So, but I'm having to draw back 2 years into my memory of working in Kubernetes to reflect on what the issue was. So it's definitely been discussed, and I could find the issues where it was discussed afterwards if people were interested.
Thank you.
Just out of curiosity, did you have scenarios when you need to also have additional Linux capabilities for application to run correctly, which you want to expose from device APIs?
I don't think we're actually running into that. We take great care for reasons of security to try and concentrate all privilege in the as much as we can in the network service manager. So, anything that had to be set up that would require a privilege, it would be handled by the network service manager before handing it off and injecting it into the pod.
But for example, to run like workload pod on the normal user, but give him, let's say, raw network capability.
Okay, no, I could potentially see that. Most people who are doing that are looking at using, so I could potentially see that. And let me go take a look. I don't think, for example, at this point that you actually have to for DPDK, which is the way most people who are looking at doing that are doing it. I don't believe that right now that DPDK requires a privileged container to give you a driver to that NIC. There was some conversation for some time about making sure that was actually true, because it was realized that privileged containers for general use are probably not a great plan. But I can go check in on seeing what the state of the work is around that. But I think we are either there or close to the point where if you have a high performance CNF, Cloud Native Network function, that needs raw access to that NIC via something like DPDK, you can get it without having to be privileged.
Okay, good.
Cool. Thank you guys for the time. I think we're right up against the edge. Any other questions?
Nope. Thank you for joining. Hope to see you in future meetings. And thanks again. And then for our next meeting in 2 weeks, if folks want to add to the agenda, please do. And we'll see you all then. Bye, guys.
Thank you for the presentation. It's very helpful.
Oh, absolutely. You guys have provided some excellent pointers as well. Much appreciated.